Hello, we will wait for 1 minute that last people connect with us. Hello everyone, we are now going to start this session. My name is Charles Tournier, I'm product testing expert and head of SenseNet France. I welcome you to this webinar entitled Smell a Fascinating Sense. This webinar is approximately 15 minutes. Do not hesitate to ask your questions through the chat windows. We will start by introducing the SenseNet group. Then we will see the physiological function of the sense of smell, how our olfactory systems works, and how we relate to odors. In 2018, the SenseNet brand was created as part of the OdorNet group, dedicated exclusively to the measurement of the odors of products and materials. The OdorNet Group is the largest odor measurement consultancy in the world, with almost 40 years of experience with practical knowledge from thousands of studies in all relevant sectors. OdorNet and SenseNet have offices and laboratories in Europe, India, and Brazil, with consultants and experts in odor analysis in all their centers. SenseNet helps its clients to improve the sensory attributes of their consumer products and material, support product development, and substantiate claims by applying its sensory expertise. Unravel and understand the molecular origins of odors and make sense of sensory. Biologically, our sense of smell serves us for many vital things. Olfaction is essential to life since odors enter through the nasal cavity, the very place through which we breathe. This means that we can stop breathing so we can stop smelling, unlike our eyes, because when we close our eyes, we can't see anything, and our ears can be blocked so that we can't hear. This is what Patrick Süskind writes in his famous book, The Perfume, in chapter 32. For people could close their eyes to greatness, to horrors, to beauty, and their ears to melodies or deceiving words, but they couldn't escape scent. For scent was a brother of breath. Together with breath, it entered human beings who couldn't defend themselves against it, not if they wanted to live. Also, we must have in mind that a few thousand years ago, before we knew how to speak and invented fire, we were a mammal like any other in nature. One of the essential pieces of information for the survival of mammals in nature is olfactory information. With olfactory information, we can detect a food source at a distance. We can also know if the food is good or not. With olfactory information, we can also do a lot of social interaction. We can recognize a congener. We can also recognize a sexual partner. Several variables are to be considered in smell and taste: olfaction, tastes, and the trigeminal sensibility. Olfaction is a sense that detects volatile molecules in the environment or in food. Tastes are detected thanks to the taste buds located on the tongue. They are divided into 5 families that we can detect: sweetness, the salty, acidity, bitterness, and umami. Aroma refers to the sensation perceived in retronasal olfaction when eating food. When we want to describe a food, we also talk about flavor. Flavor refers to all the sensations that are perceived from the mouth, including taste, retroolfaction, and trigeminal sensitivity. Trigeminal sensitivity refers to the trigeminal nerve that innervates the entire face. It is like a system alert which allows us to detect sensations such as the warmth of chili pepper, the freshness of menthol, or, for example, champagne bubbles. When we talk about olfaction, we have to imagine a dual system. There is a first system which is direct or autonasal olfaction, that is to say that odors enter through the nasal cavity with breathing and will be recognized by the olfactory receptors. This is the first olfaction. There is a second olfaction which explains why olfaction is so much linked to taste and tasting. It is the retronasal olfaction. Retronasal because during the shrink of the element in the mouth, there is a release of the odorous molecules that will go to the back of the mouth. At this point, there is a passage that allows the released molecules to go back up into the nose to be detected as well. We can thus identify molecules that are present in our food. We lose this faculty, for example, when we have a cold. If we eat a soup at this moment, for example, we can say, oh, it's salty, but we won't know if it is contains carrots or rather potatoes inside because we don't perceive all the olfactory molecules that tell us about the aromas of the food. Underestimated for a long time because it brings us back to our animality, olfaction has been the subject of much research since the 80s. Two American doctors, Linda Buck and Richard Axel, worked particularly on olfaction, winning the Nobel Prize in Medicine in 2004 for their discovery of how the olfactory system works. So, as I said before, firstly, odorous molecules enter the nose during inspiration. At the back of the nose, we have detectors called olfactory receptors, which are carried to the surface of cells called olfactory neurons. Olfactory neurons have arms, at the end of which are olfactory cilia that are bathed in mucus to trap odorous molecules. From that moment on, the molecules are in position to be recognized by the olfactory receptors. There is like a Lego game that will be set up between an odorous molecule and receptors that will be sensitive to only one part of the complex molecules. The odors will then work in a combinatorial way like a barcode. An odorous molecule will specifically activate one to several receptors, and it is these barcodes that will be read by our brain. This is called olfactory discrimination. And so, how many receptors can we have in these olfactory neurons? First of all, each olfactory neuron expresses only one receptor. But in our DNA, we have about 400 genes that will allow the synthesis of these receptors. So, we have 400 different types of receptors. In the right, we will find 1,000 of them. The champion remains the elephant with 2,000 different olfactory receptors. However, it is not because we have 400 different receptors that we can only detect 400 odors, molecules, or smells. The combinatorial system of our olfactory receptors allows us to exponentially increase our olfactory detection capabilities. It was thus demonstrated in the magazine Science that human beings has extraordinary capacities of detection in number of molecules because we would be able to detect 1,000 billion different odors. There are different areas in our brain that allow us to process olfactory information on an emotional, memory, or hedonic level. The olfactive bulb allows us to collect the information collected by the olfactory receptors and to identify each recognized molecule. It allows the transformation of chemical information into electrical information. Once processed by the olfactory bulb, the olfactory information is directed simultaneously to different areas of the brain. The orbitofrontal cortex, sensitive to all sensory information, sight, touch, smell, hearing, allows us to adopt behaviors when exposed to sensory stimuli. It allows us to make strategic choices. I approach or move away from a smell. I approach it if it is good for me. I move away if it smells burned and if it is dangerous, for example. It also allows us to imagine smells. The limbic system is an area of the brain that plays a major role in the emotional processing of olfactory. The insular cortex, linked to experience and life, allows us to feel an attraction or a disgust for a smell. The amygdala allows us to put an emotional label on a smell. It allows us to define our degree of appreciation of that smell. The hippocampus, which is our library of memories, manages episodic memory. The hypothalamus modulates homeostasis in our body and can send relaxation signals to our organs according to a sensory stimulus. Thus, because they are linked to our memory, smells are very much linked to emotion and allow us to travel back in time. Memories related to odors very often take us back to early childhood, while visual memories take us back more to adolescence. Finally, smells are particularly linked to our social and economic position. For example, city dwellers who settle in the countryside are less able to tolerate the smell of manure than farmers for whom these smells represent their history but also their source of income. Also, our culture plays an important role in our relation to odors. For example, in France, the stronger the smell of a cheese is, the tastier and better it is. Another example in Asia is about durian, which is a very odorous fruit, yet it allows Asians to prepare very fine pastries in spite of its smell, which is often judged to be very, very unpleasant. In everyday life, olfaction guides our consumption. Fragrance is an overriding choice in our intention to purchase a cleaning or a body care product, for example. We appreciate relaxing olfactory ambiances and we try to eliminate bad smells from our interior. We aim to avoid body odors such as sweat, so the purchase of a product will also be based on its odor performance. This is why odor measurement is really necessary to improve and optimize the sensory properties of functional consumer goods. So thank you for your attention and your participation, and we hope to see you soon.